Everyone, today I start about latent heat. Heat can change the temperature of the object and as well as it can change the state of substance. State of substance means solid, liquid and gaseous. When solid changes to liquid or liquid changes to vapor state, then heat is required. That means substance absorb heat, but temperature does not change. Again, when the vapor converted into liquid or liquid converted into solid, then the substance liberates heat. So due to that state change, the substance absorbs heat or liberate heats. This heat is known as latent heat. Latent heat, that means heat that change the state of substance, must be at constant temperature, is known as latent heat. But how we represent this by the graphical? Here along x-axis we plot the temperature, along y-axis we plot temperature. Here the time, here the temperature. Now when a solid is heated, then first of all its temperature increases. But when its temperature reaches to its melting point, then it starts to melt, starts to convert into liquid. That means say this is the room temperature and that object is heated from that room temperature. So first of all its temperature increases, time is going on and the temperature increases. When the temperature, here this is the temperature, when this temperature reaches to the melting point of the substance, then it starts to convert into liquid. Solid starts to convert into liquid, and that it is going on, but the temperature does not change. So the temperature remains constant and the solid is converted to liquid, solid is converted to liquid, and when it reaches here, total solid is converted to totally liquid, but temperature does not change. In that portion, solid and liquid both remains at the same time. That means they coexist. When the time is reaching at that point, then whole solid converted to liquid. Now the temperature of liquid again starts to increase. Temperature of the liquid starts to increase. It is going on. But when the temperature reaches to the boiling point of that liquid, then liquid starts to boil and it's converted to its vapor state. Here the liquid is converted to its vapor state, and when it reaches to that point, then total liquid is converted into its vapor state. Here this is the state change. Liquid is converted into gas or the vapor state. After reaching that point, then total liquid converted to its vapor state, and then the temperature again starts to rise and going on. So in that portion, here the solid transfer into liquid. Here the temperature does not change. The temperature remains constant at its melting point. Here the temperature also remains constant at boiling point, and here liquid is converted to gas. But that means in vapor. So in these two states, the graph is parallel to the time axis. That means it indicates that time is going on but temperature does not change. Here and here, in this case time is going on, temperature increases. So in this three portion, here the heats are sensible heat, but in these two cases the heat is known as the latent heat. That means latent heat change the state at constant temperature, and sensible heat change the temperature of the substance. In these two states, here the two states coexist. Solid and liquid here coexist, here liquid and gas or vapor coexist. Now take a particular example for a particular substance, here the ice. Say we take some amount of ice which temperature is minus 20 degrees centigrade. Ice at 20 degrees centigrade, if heat is supplied, then ice does not melt here. First of all, ice increases its temperature. That means temperature of ice increases. But when it reaches at 0 degrees centigrade, which is the melting point of ice, then ice starts to melt and ice starts converted to water. And when reaches at that point, then total amount of ice is converted into water, but the temperature remains at 0 degrees centigrade. That means in that portion, ice and water coexist. At that point, just at that point, total ice is converted into water, but the temperature of that water is 0 degrees centigrade. So at that point, total it is the ice, but its temperature is 0 degrees centigrade. So when the state change start, when the melting starts, then just before it, totally it is ice and it is a 0 degree centigrade. When melting is totally completed, then it is a totally water, but the temperature is also in 0 degree centigrade. Now after that, the temperature of water starts to increase, and when the temperature of the water reaches 200 degrees centigrade, which is the boiling point of water, then the water starts to boil and water is converted to water vapor. And the water is converted to water vapor. Here it is the water at 100 degree centigrade temperature. Here totally it is water vapor, but its temperature is 100 degree centigrade. In between this portion, here the water and water vapor both coexist. After reaching that point, then the water vapor, temperature of water vapor again starts to increase. This is the heating curve. This and this are the heating curve. When heat is supplied, then how the temperature of the substance changes or state change. That means when temperature is supplied to the substance, then the temperature starts increases. Then when the melting point or boiling point reaches, then it's converted into the another state. Now the another state change, that means it's reverse process. Then when the cooling is done, then what happens? In case of cooling, here the temperature in the x axis, and here the temperature, here the time axis, and it is the temperature axis. Say some amount of vapor, any vapor of any substance is taken, it is the temperature. At that temperature now starts to cool, then what will be? The temperature of vapor decreases, temperature of vapor decreases. But when this temperature reaches to the condensing point, also it is equal to the boiling point, condensing point, then vapor starts to condense into liquid, vapor condensed to liquid. Here the vapor condensed to liquid, condensed to liquid, condensed to liquid, and when here this point, when it reaches at that point, then total vapor is converted into liquid. Now the cooling is already happens, so the temperature of liquid again starts to decrease and starts to decrease, and when the temperature reaches at a point which is a freezing point of that liquid, then liquid again starts to freeze into solid, liquid starts to solid, and at that point here the total liquid is converted into solid, then again the temperature of the solid starts to decrease. This is known as the cooling curve. When the vapor is cooled, then its temperature first decreases. When it is reaches at the condensing point, then it starts to convert from vapor to liquid, and at that portion vapor and liquid coexist. When the graph is reaches at that point, then the total vapor is converted into the liquid, then the liquid temperature of the liquid starts to decrease and decrease and decrease, and when it is coming at the point, at the freezing point, at the temperature freezing point, then the liquid starts to convert into solid, and after that at certain time total liquid changes to solid, and then the temperature of the solid changes. Here the state change occurs. That is why the graph remains parallel to the time axis. That means the temperature does not changes, only the state change happens here. But in these three cases, here the temperature changes with time, because here no state change is there, only the temperature of the substance changes. This is known as the cooling curve. Thank you.